Hi all, let's see the next topic of input output organization, which is modes of transfer and programmed IO. Coming to today's lecture, we are going to discuss about an introduction to modes of transfer. What are the different modes of transfer? And then we move on with the one of the mode of transfer, which is programmed IO, and then the drawbacks of programmed IO. Coming to the introduction, when a communication has to take place between the CPU and the input output peripherals, the binary information which is transferred between the CPU and the input output devices actually stored in the memory unit of a computer. We say that the communication is taking place between the CPU and input output devices, but the before the information from the peripheral reaches the CPU, it is first stored into the memory unit of the computer. From the memory unit, the CPU is going to access the particular information. Similarly, when a CPU has an information that has to be given to the output device, such as monitor, it will be first stored into the memory unit of the computer. From the memory unit, the information is given to the output device. So, the binary information that is received from an external device, it is usually stored into the memory unit of the computer. The information that is transferred from the CPU to the external device or from the external device to the CPU, it is originated from the memory unit. And the CPU does not merely process the information, but the source and the target is always the memory unit. Only during the dynamic runtime of your program, when you have to take the input from the keyboard, then the CPU will process that particular information or directly take the information from the input output device. Other than that, the information is first stored into the memory unit and then given to the CPU for execution. So when the data transfer takes place between the CPU and the input output devices, it can be transferred in three modes. One is a programmed IO, the second one is an interrupt initiated IO, and the direct memory access. There are three methods of data transfer that exist between the CPU and the input output devices. Now let us see each one in detail. The first method is the programmed IO. As the name implies, the programmed IO is nothing but the method of the data transfer takes place with the help of a program. That's why we call it as a programmed IO. Here, the transfer of data between the CPU and the input output devices takes place with the intervention of the CPU. So the programmed IO operations are the result of IO instructions which are written in a computer program. So here the input output device doesn't have a direct contact with the memory unit. So it has to take the intervention of the CPU in order to enable the data transfer. So each data item transfer, it is initiated by an instruction that exists in the program. So the transferring the data under a programmed IO, it requires the constant monitoring of the peripheral or the corresponding IO device, and that is done by the CPU. So once the data transfer is initiated, the CPU has to require the interface unit of the particular IO device to see when a transfer can again be made. So in case of a programmed IO, the IO device that want to transfer a data to the memory unit, it doesn't have a direct access to the memory unit. It is used to transfer the data between the IO and memory with the intervention of the CPU. And here the transfer takes place one byte at a time. So if you say, for example, I want to give as an input from the keyboard the hello message. So here each and every character of your English alphabet is considered as an 8-bit ASCII value. So which is nothing but one byte. So at a time, only one byte of information will be transferred from the particular peripheral device into the memory unit. So byte by byte, the information transfer takes place. So the device transfers the bytes of data one byte at a time as and when available. So when one byte of information is available, the device or the corresponding peripheral device places it onto the IO bus. So let me show you how this transfer takes place between the input output device and the memory unit of a computer. So this is a diagram which explains you about a data transfer that takes place. So this is my IO device and we have a memory unit that is connected to your computer, and the CPU is responsible for taking the input from the input output device to the interface unit of the corresponding device and copy the data into the memory there exists a CPU and an IO device. Between the CPU and an IO device, there exists an interface of the corresponding IO device, which acts as an intermediate in transferring the information from the IO device to the CPU to the memory unit through the intervention of the CPU. So, say for example, you want to transfer the information from the keyboard to the memory unit which is present in the CPU. So the corresponding keyboard is said to be called as an IO device here. So this is an interface unit of the corresponding keyboard. So whenever the keyboard has an information, say the keyboard want to give an information, a hello message through the keyboard that has to be stored into the memory of your computer. In that case, each and every character is considered as one byte of information. So first it starts giving the first character H, which is taken as a 8-bit ASCII value, which is considered as a 1 byte. So that particular 1 byte of value is placed onto the IO bus. The peripheral device or the keyboard places that data onto the data bus, and it will enable the data valid signal. So whenever a data valid signal is enabled, it is an intimation to the interface unit of the corresponding peripheral device that valid data is placed on the data bus or IO bus. Okay. So whenever the interface unit identifies the enable of the data valid line, it will copy the corresponding information from the IO bus and place it into one of its registers called as a data register. So in the information is not directly transferred from the IO device to the CPU. It will be first transferred into the interface unit. From the interface unit through the intervention of a CPU, it will be transferred to the memory unit of the computer. So the interface unit of the corresponding keyboard, it transfers the information present on the IO bus into the corresponding register, which is the data register. So once the data register has an information, the corresponding interface unit has uh, has a flip flop called as a F flag bit. The interface unit has a flag bit F. If this flag bit is set to 1, it indicates that there is an information that exists in the data register. So the once the data is copied from the IO bus into the data register, the interface unit will set its flag bit to 1. So whenever the flag bit is set to 1, automatically the interface will enable the data accepted line. So this data accepted line is an acknowledgement to the corresponding keyboard that the information is accepted by the interface unit of the corresponding peripheral device. So whenever a the CPU keeps on checking the flag bit of the corresponding interface unit to check if there is any information that has to be copied into the memory unit of the computer. So whenever CPU identifies this flag bit is set to 1, then it will enable the IO read operation or it enable this IO read line so that the information will be copied from the data register into the corresponding memory unit of the computer through this data bus. It places this information on the data bus and the information is copied into the memory unit of the computer with the intervention of CPU by enabling the IO read operation. So this is how the CPU reads the information from the corresponding peripheral device, which is an input device such as keyboard, and place it into the memory unit of the computer. Similarly, if the CPU has an information that is stored in the memory unit and that has to be given as an output to the output device such as monitor, in that case, it enables the corresponding IO write operation, IO write line, and the corresponding address is placed on the data bus. So which output device it wants to access. The monitor's address will be placed onto the address bus, and it will enable the IO write operation so that the information will be placed into the corresponding interface unit of the output device, which is monitor. From the data register, the information will be copied into the corresponding output device. So there are three tasks that has to be done by this. It reads the status register. The CPU will read the status register and it's check the status of the flag bit. And if the status register is not set, if it is 0, it indicates that there is no information. So it again branches to step 1. So it keep on checking the status register, the flag bit of the status register, to determine if there is any information that is existing in the data register. So whenever the status register flag bit is set to 1, then it reads the data from the data register. And if it is 0, if the flag bit is not set, Then it again moves to it again keeps on checking the status register until its flag bit is set to 1. So if you see the data transfer handshaking sequence in this particular method, the corresponding IO device places the byte of information onto the data bus, and it will enable the data valid line. So once it enables the data valid line, the interface unit of the corresponding IO device, it will accept the particular byte of information which is present on the bus, and it will enable the data accepted line. So it will set the flag bit. At the same time, it will also enable the data accepted line. So once the peripheral device comes to know that the data accepted line is enabled, then it will disable the data valid line. Next, the CPU, when it identifies the flag bit is set, then it reads the data from the corresponding data register of the interface unit. And once the read operation is done from the data register, it will clear the flag bit back to 0. And whenever the flag bit is clear to 0, the corresponding interface unit, it will disable the data accepted line. So this ends the one byte of information. So the next byte of information, the next character will be taken from the keyboard, and again it can be placed into the corresponding data register of the interface unit. So this is how a data transfer handshaking sequence works between the CPU, interface unit, and input output peripheral of a computer. So from the CPU point of view, what happens? So as we know that whenever the information is available on the IO bus, the particular interface unit of the corresponding peripheral device will copy the information into the its corresponding data register, and its flag bit will be set to 1. So the CPU keeps on checking the flag bit of the corresponding interface unit to determine whether there is an information present in the data register. So the CPU will keep on checking this flag. If this flag bit is set to 1 of the corresponding interface unit, it will read the status register, and it transfers the data to the memory unit of the computer. So if the entire data transfer is complete, say hello message I want to send from the keyboard to the memory. So first byte will be H. The second byte I have E. L. Similarly, 5 characters, 5 bytes of information. But at a time, only 1 byte of information can be transferred from the input output peripheral to the memory. So when 1 byte is done, if the information is not, operation is not yet complete, again it will go back and read the data register for the next byte of information. So it will check the flag bit. If the flag bit is still 0, then it will keep on waiting until the peripheral device copies the data. It places the data onto the data bus, and the data is copied into the data register. So here, if the operation is complete, it will continue with the remaining program. And say for example, every time the CPU needs to check the status register here. So for the flag bit. So if the flag bit is 0, the CPU goes into the loop and keep on checking the flag bit. So this it loops continuously. So what's happening is when there is no data available in the data register of the corresponding interface, the CPU is wasting its time checking the flag bit rather than performing some other operation. So the main aim of a CPU is execution of the user instruction programs or instructions, but here the CPU time will be is getting wasted checking the status register. So it goes into the loop. If the flag is 0, the CPU will be continuously in the loop until its flag bit is set to 1. So that is not the main aim of the CPU. Its main aim is to execute the programs and increase the throughput of the computer system. So here the CPU is wasting most of its time, which is one of the major drawback of the programmed IO. So the CPU check the status register and IO interface for the flag bit. If your flag bit is 1, it reads the data from the data register and transfers it to the memory unit. If the flag bit is 0, it again loops and keeps checking until the flag bit is 1. So here it is the responsibility of the CPU to keep checking the flag bit, and it is not the responsibility of the interface unit. The interface unit just places the data into the data register and it is not bothered about whether the CPU will read it or not. It is the responsibility of the TPU to keep checking the status of the corresponding interface and then read the data from the corresponding register. So if your flag bit is 0, the CPU is continuously goes into busy wait, not performing any type of operation. This is a flow chart. So next, coming to the drawbacks of a programmed IO, this mode of transfer is said to be one of a very inefficient approach because of its major drawback. So the major drawback here is the CPU has to keep on monitoring the interface unit all the time and the program is executing. So the CPU has to stay continuously in a program loop until the IO unit indicates that it is ready for data transfer. So how does it shows that it is ready for data transfer with the help of a status register's flag bit. So that here the CPU is wasting its time checking the flag bit rather than executing the programs. So it is the responsibility of the CPU here to keep checking the status register of the interface, and then if the flag bit is set, then it has to transfer the information to the memory unit. So here the lot of CPU's time is being wasted, which is a major drawback of programmed input IO. So in order to remove this problem, we and another approach which is called as interrupt initiate IO is used. Let us see about interrupt initiated IO in the next lecture. Thank you.